Okay. So, do I talk now?
Yeah, please begin.
Okay.
So,
Okay. Thanks for sharing a simple introduction. And in this talk, I will talk about how the time emerges from the quantum entanglement or the unitary equivalence. And then one collaborator is Chris. He's a postdoc at the Kobe University now. Okay. And first, I want to show how time is abstract, more than the space. And let's remind how to define the time from Aristotle first. Aristotle defined time as the measurement of change. So this means that if a thing does not change, then you cannot see the time flow. And Newton doesn't agree with this idea or definition. He thinks that time is absolute and it should be independent of things that change. Let's see one example from this class, and you will see the difference between Aristotle and Newton's definition. Aristotle thinks that this gas is full of air, but Newton will say that inside the gas is just empty. So now you can see how different from their definitions. So there are differences that Aristotle does not think that you can have the ideal time or ideal space-time there, but Newton thinks that we should have this space-time there. So at that time, it's hard to understand this question. After Einstein developed his gravity theory, then he can answer this question. Because this space-time still exists, even if you do not have matter. So it implies that Newtonian time exists, but not absolute. So this means that Newton's definition is correct, but he is not all correct. For example, Einstein also showed that nothing changes does not imply that this time is independent from the things. So, for example, if people live in a room with different heads, the measurement of time will be different. So in other words, even if nothing changes, time still depends on something. But so this means that Newton's proposal, independent of things that change, is also wrong. But however, we should remind it, Aristotle and Newton they are in the very old time, but they already captured almost ideas. But however, now I think due to experimental science and many theoretical studies, we think that Einstein's definition is very good, at least for the classical level. Now let's move to the content. Okay, or the holographic entanglement entropy. In the principle in the holographic entanglement entropy, it mentions that a CFT's entangled entropy is due to the ADS minima surface. So in other words, the space-time emerges from quantum entanglement. So the definition of time should, so the definition that I state, the definition of time should be just due to the macroscopic effect, not due to the microscopic. So that we can always think about how to use the quantum entanglement to generate the emergence of time or classical time. But this picture, I mean the entanglement geometry correspondence is still hard to do. Let me remind one famous mathematical question. Here's Sharper drawn for this figure. If this question is equivalent to asking if a person knows the frequency, could a person know the Sharper drum? Now, the mathematician already showed this answer. The answer is no, because even if you know two different frequency, the Sharper may be the same. So this means that the frequency isn't enough to let us know the complete information. So this is the issue about a geometry entanglement corresponds or ADS correspondence. So if a proposal want to work, then entanglement spectrum should provide the distinguishable constraint. So I want to generalize the unitary equivalence equation 1 to a more arbitrary state. Initially, this unitary equivalence is inspired by the Sommerfeld double state, equation 2. H head MOD is defined by minus log trace 1 of a reduced density matrix. Trace 1 is a partial trace operation of the first region. And the beta is the inverse temperature. And U hat is a general unitary operator. And EM is an energy spectrum. And H0 can be obtained by partial trace over the first region of the total system Hamiltonian, equation 3. So hence we can give the complete description to the unitary equivalence or more general description for the equation 1. Later I will apply this relation to the quantum chaos quantity and see how the emergence time should appear from the modular flow. The first chaos quantity is OTOC. Here I introduce the regularized sum of I regularize the sum exponent value by inserting some factor is minus 4 beta h. And when t goes to infinity, and the exponent lambda is lambda, which is the quantum analog of the classical Yapon exponent. In the classical picture, if two trajectories are close to each other initially, but after a long time evolution, then you will see the very large difference, and similar to the exponent lambda t. Then the positive lambda or positive Yapon exponent can show the sensitivity on. That implies that the system should be sensitivity on initial conditions. And the Martina, Schenker, and Stanford in 2016, they show that lambda should be bounded by 2 pi over beta. And they also gave a conjecture. The saturation of the chaos bond in a unitary boundary theory implies ADS Einstein gravity. This conjecture is very interesting because it gives a direct connection between the holographic principle and the quantum chaos. Okay. The second chaos quantity is low stream echo. This quantity, low stream echo with a modular Hamiltonian. So you can find that the modular evolution operator define the the time evolution operator replaced by exponential I HO MOD T. So I replace Hamiltonian by a modular Hamiltonian. And when T goes to infinity, then you can also see the bound, and this bound. So you can also see the exponent lambda, and this lambda is bounded by 2 pi, and which is called the modular chaos bound. And this bound is generated by the difference between the two modular Hamiltonian operators. And the saturation, if the saturation happens, then it implies that the most sensitive infinitesimal perturbation on quantum state. So you will find that the chaos bound and the modular chaos bound give the different physics, but later I will show that they can be related to each other if you include the unitary equivalence. So at the first, I introduced the setup in the Fermionic theory. The Fermionic coherent state is given by equation 6, and which can also be generated by the displacement operator d hat. We can consider the operators equation 8, and which can be separated into 2 parts, S hat and the T hat. And when T hat acts on the coherent state, then it generates a shift. So you can find that this operator is similar to the momentum operator because the momentum operator P hat acts on the bosonic coherent state. You will also see the shift. So indeed, this operator U hat is inspired from the group element of the Heisenberg group, equation 12. And before, people already show the duality between the OTOC and the Nordstrom echo in the bosonic theory from this from equation 12 of these operators. And because S hat, P hat are similar to the S hat, T hat, so we will also use a similar way to show this duality in the Fermionic theory. And then this proposal is not just restrict to the quantum mechanics. You can use a similar way to generalize the duality to the quantum field theory. So it's why we are interested in this direction because it can be extended to it's possible to apply to the conformal field theory, and our duality is correct for any theory, although we consider the specific operators. We consider the total system Hamiltonian, equation 13. For the first two terms, which is the same as the case of the thermal field double state. And we also introduce the third term, random iteration. And in the OTOC, we first consider the beta equals to 0. So integration of a psi means the trace operation. And this OTOC operator, we consider the sum of the different operators. So it corresponds to the integration U1 hat, U2 hat. It's equivalent to doing the integration over the alpha and the gamma in the equation 8. And this operator U1 hat of T1 is localized, means that this operator localized on the first side at the time T1. And after we partial trace over first region, then the OTOC will become the Nordstrom echo with the sum over different operators P1 hat, P1 hat prime. And N1 is an operator, is a number of operators P1 hat or P1 hat prime. And then I think that is expected the sum over the P1 hat and the P1 hat prime is expected because OTOC, well, in the OTOC, we also sum over the different operators. So now I say how to introduce the temperature 1 over beta. We regularize some expectation value by shifting the time parameter as in the equation 15. It's equivalent to inserting the thermal factor to do a regularization. We then can introduce the modular parameter S defined by T over beta and use the unitary equivalence to replace the subsystem Hamiltonian with the modular Hamiltonian. This replacing does not change anything. It's just a field definition. So in some sense, now you can see the Nordstrom echo with a modular Hamiltonian operator is due to the OTOC. But it's very non-trivial because the Nordstrom echo with the modular Hamiltonian is placed by the modular Hamiltonian. But the dual operator correlated OTOC is expressed by the total Hamiltonian. And then you can see a non-trivial link between the modular chaos and the chaos, modular chaos bound and the chaos bound. And because we consider the space-specific set of operators, so we do not speculate in any context of quantum gravity. In any scale, quantum gravity can heavily have the unitary equivalence. So our picture is that if for a UV quantum gravity, we can use the modular flow or the modular Hamiltonian to do the involution. But if it goes into a very low energy, then you will find this modular flow is due to the physical time flow. So it's why we say that this proposal can see the emergence time. And then indeed, this proposal can also apply to the TFD state or thermal field double state. So we can also study the APCTP correspondence for this emergence time proportion. And then when the late time, only the greatest exponent survives. So hence the dual also implies the modular correspond equals the correspond if we have the constraint of the unitary equivalence. So we know that the correspond can, if we saturate the correspond, then we can get then it implies the Einstein gravity theory. But now modular correspond can also imply Einstein gravity theory due to the dual. But let me remind it, modular correspond and the correspond give the different physics, but now they are equal. So this means that we have a more constraint to help explore the Einstein gravity. So hence we expect the unitary equivalence should be useful to the ADS-0 correspondence and study the Einstein gravity theory. Thank you for listening to my talk.
Okay, thank you. You have made very good. Okay, so question.
So in your title, you are mentioning about the emergence of time. So could you explain again what is the relation with the unitary equivalence and emergence of time?
Okay, initially we consider a very specific set of operators. We speculate unitary equivalence only holds in the IR scale gravity theory. So only when we have this unitary equivalence, then the modular time flow will be related to the physical time flow. So for the UV scale, we do not have we possibly to lose the unitary equivalence. So we only can define the gravity theory's flow by the unitary flow. But when going to the very, very low energy scale, then a modular flow will be relevant to the physical flow. Then you can see the emergence of time. Yeah. So I think that our example gives a very concrete realization for understanding the unitary flow to the physical time flow. I think this study also relevant to the gravity theory community for thermal time hypothesis. Yeah, we just give a concrete realization for the thermal time hypothesis.
Okay, other questions? Okay. I'm sorry, but I don't know how does it happens, but I want to ask one thing. So in your case, you argued that the system evolve unitarily.
Let me think whether I need this condition. I think so, because in the OTOC we should require it. Yeah, if we want to understand Einstein gravity theory.
So in that case, how does the chaos appears?
Huh?
How does the chaos appears in quantum theory?
In the quantum system? Okay, at the first, okay, because when it depends on how you say chaos first. So in your mind, how you define the chaos in your sentence? Yeah, is my question for you first. Yeah, because we can really use the conformal field theory and to capture the Yapon exponent, and then you will see the positive Yapon exponent. Yeah, so it's the one chaos phenomenon. Yeah, sure. So but I think later you may want to ask other things.
As I know, that is the result of the chaos. With the reference exponent is just the result.
Yeah. So yeah, it's very interesting. So when I say the chaos bomb, I do not say the system must be the quantum chaos system. I just say that it's a one chaotic phenomenon. Yeah, okay. So, and indeed we do not have any concrete definition to define quantum chaos. And many people say different things. Yeah.
Okay. So other questions?
I have some very naive question about. I think you are an expert on this aspect. So my question is naively because so I noticed that recently people study a lot about quantum complexity. So how is your and I don't know if I understanding this wrong. So how this your chaos those quantity related to the complexity?
I will not say that we do not have a very concrete relation to define the relationship between the quantum chaos and the quantum complexity, but naively, Yapon exponent can roughly say the order of complexity. Yeah, but it's very sloppily to say this point, not very quantitative to say this point. Yeah. Usually, I think that you can say concrete for the very late time limit. It's maybe concrete enough. Yeah.
Okay, probably we can discuss this.
Yeah.
Thank you.
Other questions?
So as I understand, you claim that the time is some concept only in macroscopic system.
Yeah.
Claim?
Only for the microscope. I think it is also how you say. When I say the time, I mean the classical time that we can feel the time. Yeah. So for this time, it's only due to the microscopic.
Okay, so the macroscopic system case, there is some irreversibility, right?
Mm-hmm.
So there's inconstant with some unitarity.
Yes.
So can you say that some relation between the irreversibility and unitarity? So usually unitarity require the reversibility.
Yes.
Right?
Yes.
But if you consider some temperature, so like the summer system, then so if you consider some molecular only.
Okay. So for this case, I think that you can also see the gravity community is a simultaneous hypothesis. Okay. In this case, I think you do not have the true time because you lost the time reversibility. But so you can use the thermodynamic entropy to define the time. Then you can see the entropy, how entropy grow. Yeah.
But in that case, that is not summer system. So there is irreversibility.
Oh, you say this system is not
So
something.
usually there is that system is not unitarity.
Then I don't know. Usually we still need to have the thermodynamics to define the time. Yeah. The entanglement, but the entanglement entropy can be here. We do not need to introduce a temperature indeed, because modular Hamilton can be done.
So the reason why we consider some islands to explain some record information, so there's crucially related to unitarity, right?
Yeah.
So maybe to we obtain some unitarity, maybe we need some new concept like island.
Oh, okay. For this point, I agree. Yeah. For this point, I agree. Yeah.
Other questions? Okay. Great, thanks to the speakers.